You have learned the tools: Burp Suite, SQL Map, Postman security testing, JWT attacks, IDER testing. But tools are not what makes a good security tester. What makes a good security tester is how they think. Professional penetration testers and bug bounty hunters do not just run through a checklist. They think about systems. They ask what assumptions this design makes. They look for places where those assumptions break down. They think about combinations of weaknesses that individually seem minor but together create a critical vulnerability. They think like attackers. That sounds dramatic, but it is a learnable skill. Attackers are not magical. They are methodical. They understand systems. They are patient. They look for the path of least resistance. The difference between a QA engineer who tests features and one who finds security bugs is usually not knowledge of a specific tool. It is whether they have made the mental shift. Threat modeling is the practice of systematically thinking through how a system could be attacked before you start testing. The most widely used framework is called STRIDE. Each letter stands for a threat category: spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. Let me walk through each one with a concrete example. Spoofing: can an attacker pretend to be someone they are not? Can they forge a JWT token? Can they spoof an email address in a password reset flow? Can they impersonate another user by manipulating an identifier? Tampering: can an attacker modify data they should not be able to modify? Can they change a price in a shopping cart request? Can they modify another user's records? Can they alter a file after it passes validation? Repudiation: can a user deny performing an action and have no way to prove otherwise? Does the application log enough information to reconstruct what happened? Can log entries be modified? Information disclosure: does the application expose data it should not? Error messages with stack traces? API responses with sensitive fields? Logs written to accessible locations? Denial of service: can an attacker prevent legitimate users from using the system? Missing rate limiting? Resources that can be consumed without authentication? Long-running operations that can be triggered freely? Elevation of privilege: can a regular user gain admin capabilities? Can an unauthenticated user access authenticated functionality? Before you start a testing sprint on a new feature, spend 15 minutes applying STRIDE to it. You will write better test cases and find bugs faster. Exploratory security testing is what happens after you have run through your checklist and you still have time and curiosity. Unlike scripted testing, exploratory testing has no fixed set of steps. You start with a target and a charter. The charter is a focused question: what can a user do to other users' data? Or, what happens when you interact with the payment flow in unexpected ways? Or, can you abuse the admin functionality from a regular user account? You then explore freely, using your knowledge of the system, your intuition about where weaknesses might be, and the techniques you have learned. Some of the most valuable security bugs are found this way. Not because the tester followed a specific technique, but because they were curious about something that seemed slightly off. A few heuristics for exploratory security testing. Look for state transitions. Moments in the application flow where something changes, you become authenticated, you move from one step to another, you transition from a free to a paid account. These are places where the application has to correctly update its internal model of who you are and what you are allowed to do. They are disproportionately likely to have bugs. Look for trust boundaries. Places where data moves between systems, the client to the server, one microservice to another, your application to a third-party API. Each crossing is a place where trust assumptions might be violated. Look for assumptions about ordering. What happens if you complete step 3 before step 2? What if you repeat a step that should only happen once? What if you complete the first half of a flow and then pause for an unexpected amount of time? These are the questions that reveal logic bugs that automated scanners cannot find. Bug bounty programs have produced some of the most creative security research in history. And the mindset that top bug bounty hunters apply is directly transferable to QA security testing. The core principle: read the documentation and then ignore it. Documentation tells you what the system is designed to do. Attackers do not care about that. They care about what the system actually does when given input it was not designed for. Top bug bounty hunters spend a lot of time reading API documentation, understanding intended behavior, and then asking, what does the application do when I violate those intentions? What if I send a field the documentation says is read-only? What if I call an endpoint in an order the documentation does not describe? What if I combine two features that were never intended to interact? This is called abuse case testing. Instead of writing use cases that describe intended behavior, you write abuse cases that describe how an attacker might try to misuse the system. For every feature you are testing, spend 5 minutes writing down abuse cases. A user profile that lets you enter a website URL. What happens if that URL is a JavaScript link? A search field. Can you exfiltrate data using timing attacks? A file upload. Can you upload a file that triggers server-side code execution? The other thing bug bounty hunters do is chain vulnerabilities. An individual finding might be low severity on its own. But a low severity information disclosure that reveals internal IP addresses, combined with a server-side request forgery vulnerability, might allow an attacker to reach internal services. Context changes severity. When you are reviewing security findings, always ask, what else would an attacker need to make this worse? What could this be combined with? Let me give you a practical framework for approaching a new application from a security testing perspective. Step 1. Map the application. Before you test anything, understand the architecture. How many user roles are there? What are the main data objects? Where does data enter the system? What third-party services does it integrate with? Draw it out if it helps. You cannot test what you do not understand. Step 2. Identify your highest value targets. Not all of the application is equally interesting from a security perspective. Focus your effort on authentication flows, payment processing, administrative functions, data access controls, and any place where sensitive data is stored or transmitted. Step 3. Apply stride to your high-value targets. For each one, go through the 6 threat categories and generate specific test cases. This is your structured security test plan. Step 4. Execute the structured tests. Run your test cases, document results, file bugs for findings. Step 5. Explore freely. After the structured phase, spend time doing exploratory testing on the parts of the application that felt interesting or slightly off during Step 4. Follow your intuition. Step 6. Chain your findings. Look at your findings holistically. Are there combinations that create more severe vulnerabilities than any individual finding? This process works whether you have 2 hours or 2 weeks. Scale the depth based on the time available, but always do steps 1 and 2. Understanding what you are testing is the foundation of finding anything interesting. Here is what we covered. The pen testing mindset is a shift from testing what the system does to testing what the system prevents. From use cases to abuse cases. From expected input to unexpected input. Threat modeling with Stride gives you a structured framework for thinking about threats before you start testing. Spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege. Exploratory security testing finds bugs that checklists miss. Focus on state transitions, trust boundaries, and assumptions about ordering. The bug bounty mindset: read the documentation and then violate it. Chain low severity findings into higher severity vulnerabilities. Look for combinations. The practical framework: map the application, identify high-value targets, apply Stride, execute structured tests, explore freely, chain findings. Security is not a special mode that you switch into for a security audit. It is a lens you apply to everything you test. The engineers who become valuable security testers are the ones who apply that lens habitually, not just occasionally. Final episode next: writing security test cases and security test reports. How to document what you found in a way that gets action, how to write test cases that live in your regression suite, and how to communicate security risk to stakeholders who are not technical. Subscribe to QA Career Lab. I will see you there.